All right, so we're going to take a look at the 2021 chapter competition. We're looking at the sprint round problems 21 through 25. So, the triangle ABC has side lengths of 11, 15, and 16 inches. I'm going to draw that really quickly. So it's going to look something like this: 11, 15, what is the altitude of the side length? Okay, it's 15 and 16. What is the altitude? Now, the altitude is the perpendicular distance from the top of the triangle to the bottom of the triangle. And it says express your answers in simplest radical form. Now, the first thing I really would like to do is to turn this into a Pythagorean theorem problem. The problem with that is I can't, because I do have my right triangle here. I have two right triangles, one here, the other one here. But the thing is, for each of them, I only know one side, and I can't make a variable that I can use for both the altitude and the fraction of the base. I just can't do it. But luckily, there's a way to find the area of a triangle without knowing the base and the height, and that is Heron's formula. Heron's formula says that the area of a triangle is equal to the square root of the semiperimeter times the semiperimeter minus A times the semiperimeter minus B times the semiperimeter minus C. Now this looks bad, but in reality it's not. So this way I can find the area, then I can use what I know about base times height divided by 2 to find the altitude of my triangle. So the semiperimeter, well, I add all these together, so it's 11 plus 15 is 26, 26 plus 16 is 42, half of 42 is 21. So S is 21. So that means the area is equal to the square root of 21 times 21 minus 11 times 21 minus 15 times 21 minus 6. I'm running into my triangle. All right, so we know that the area is going to be equal to the square root of 21. Well, 21 times minus 11 is 10, times 21 minus 15, which is 6, times 5. Now, I could multiply this together and try to get simplest radical form, but that would be crazy, insane, long. So what I'm going to do is I'm just going to turn each one of these numbers into its prime factorization. So we have the square root of 3 times 7 times 2 times 5 times 2 times 3 times 5. All right, well, I have a 2 and a 2, so that means that's going to go on the outside because 2 times 2 is 4, square root of 4 is 2. I have two sets of 3s, so that's another 3 on the outside. I have two sets of 5, so that's going to be 5 on the outside, and then I have this leftover 7. So I know the area of the whole triangle is going to be 2 times 3 times 5. Well, 2 times 3 is 6, 6 times 5 is 30. So we have 30 square root of 7. That's the area of the whole triangle. And we know that's going to be equal to half the base. Well, the base is 15 times the height. Let's call that h. So, well, multiply both sides by 2. So I get 15h is equal to 60.
Dad, the Olympics in 1940 were canceled.
I'm not surprised. Divide by 15, divide by 15. And I get h is equal to 4 root 7, which I believe is the correct answer. All right. Julie packed some marbles. She doesn't want to lose them. And she packed them, she had 815 marbles, and she has boxes of 10, 25, 50, and 100. And she has to fill the boxes, and she can't have more than 5 of each box. What is the minimum number of boxes she can pack all her marbles in? Well, so if we have 815 marbles, well, we need to get down to the least common well, we have to use this 10, boxes of 10, to get down to the a multiple of 25. So to do that, well, if I subtract 4 boxes of 10, that would get me to 775. So right now I've used 4 boxes, that gets me to 775. Well, so now I really want to get down to a multiple of 50, so that way I can use my boxes of 50s and 100s. And I know I'm going to have 5 boxes of 100 right off the top of that, or right away. So then, well, I just need 1 box of 25, and that's going to get me to 750. Well then, okay, so now let's use our 5 boxes. So that is, so let's use a box of 50. Oh my goodness gracious. So this one box is 25. So then let's use our boxes of 50 to get to 700, because then I can use all of my 100 boxes, and then whatever left over I can use my 50s. So that's 1 box of 50. Well, now I can use my boxes of 100, so there's my 5 boxes of 100, and then so that means I'm going to need 4 more boxes of 50, and then 5 plus 1, okay, 4 plus 1 is 5, I don't go over. So if I add this up, 4 plus 1 is 5, 6, 11, 15 boxes. That one was actually legitimately quick. All right, now 23 is kind of one of those super cool properties of exponents that everyone knows and loves. Not really, but here we go. So we know that the 6th root is the same thing as having a denominator of 6 in an exponent. So I can write this this first term here as, oh, I'm trying to find what x is. So I can write this as x to the 7/6 power minus 6 times x to the 2/3 power. All right. Well, this is kind of gnarly because I have 7/6 and 2/3. I really want a common denominator. So I know that 2/3 is the same as 4/6. That makes life a little bit easier. All right. Oh, no way. So now I know that 4/6 or x to the 4/6 goes into x to the 4/6. Obviously, that's, you divide out, you get 1. But 4/6 also goes into 7/6. So x to the 4/6 goes into x to the 7/6 evenly, and now I would be left over with 3/6, right? So this is a cool factoring out the greatest common monomial. So I can factor out the greatest common monomial of x to the 6/4, and that's going to leave me with x to the 3/6. Wait a second, 3/6, that's just the same as 1/2, isn't it? Because 7 minus 4 is 3. All right, so that's 1/2. That's 4. Nope. There we go. X to the 1/2, and then minus 6, because x to the 4/6 divided by x to the 4/6 is 6. Well, wait a second. If you have an exponent of 1/2, that's just the same thing as taking the square root. So what number, the square root of what number is equal to 6? Because we need to subtract 6 to get 0, and so x has to equal 36. All right. These are tricky. What fraction is equivalent to 0.712, and the 1, 2 is repeating? Express your answer as a common fraction. Well, so the first thing I need to realize is I'm kind of dead in the water until I decide to use a variable, because I'm going to have a hard time. So I'm going to say that x is equal to 0.712. All right, that's not too bad. Well, if that's the case, so I want to set up an equation that gets me x is equal to a number, and when I get x is equal to a number, then I know what x is, right? So then I need to make it so that this repeating part is the only part after the decimal place. So if I say that 10 times x, well, if I multiply this decimal by 10, I'm going to get 7.12, and now the 1, 2 is repeating. Oh, okay. Well, using that logic, 100x would be equal to 71.21 repeating. But you know what, that's not really helpful, because if I try to subtract these two, I'm gonna still get a decimal that goes on forever, which is not helpful. So let's look at 1,000 times x, and that's 712.12, and that gives us the 12 repeating again, which is really nice. So I know that 1000x minus 10x has to equal 712.12 minus, so we have this minus 7.12, and these 0.12 is repeating, but if I subtract them, they will cancel out, and so I just get 990x is equal to 705. Well, okay, divide by 990. And so I get x is equal to, well, okay, so I know 5 goes into it, and I know 3 goes into it, because I do. Because 7 plus 5 is 12, which is divisible by 3. 9 plus 9, well, 9 is just divisible by 3, right? So if I divide both of them by 15, I will get 47 over 66. So this one actually wasn't terribly long either, if you know how to set it up. All right, finally, it's Pythagoras and the tangent circles. And we're trying to find what is the radius. We're trying to find what is the shaded, what is the radius of the shaded circle. All right, so first things I realize, I know that this distance from here to here has to be 4, because the radius here is 1, right? What else do I know? I know that the center of the circle is going to be somewhere right about here. Oh, that's going to set up a right triangle. No way! Okay, all right. So then, all right, well, so what's this distance here, right? So this is my radius, right? And then I have a 1 extra here, because the radius goes to here, and I have 1 extra. And then this distance here, well, if I continue this radius from here all the way up, we know that this distance here is going to be 5 minus my overall radius, because here's the center point of my... All right, so we got Pythagoras. Let's go. So we have a squared plus b squared is equal to c squared, which means we have 5 minus r squared plus 4 squared is equal to r plus 1 squared. Okay, so let's multiply these, or let's square these things. So we get 25 minus 10r plus r squared plus 16 is equal to r squared plus 2r plus 1. All right, so these r squared, since they're on both sides of the equal sign, they'll cancel out. So we get negative 10r, I'm going to add 25 and 16, that's 41, is equal to 2r plus 1. All right, so now I'm going to add 10r to both sides. So I get 41 is equal to 12r. Subtract 1 from both sides, I get 40. Divide by 12, divide by 12, and so I get the radius is equal to, well, 4 goes in both of them, 10/3. So all of these problems actually weren't as bad as they looked. The trick is you need to know how to get in there and use what you know about it.